So today I will explain about the experiment that we will do today. So basically our experiment is about to assemble data to see what happened to the temperature against time. So firstly I will explain about the equipment and the apparatus that we will use in the experiment. So firstly we are using two heater, which is one of the water bath and also the direct heater. Next one we will use the thermometer and also beaker, and then this one is water bath, and we set the temperature at 40 degrees Celsius as our first set point. This is a heater. We will use this heater to maintain the temperature at 40 when we want to change the set point to the 80 degrees Celsius. We're using distilled water with volume 500 ml. This is our apparatus. We are using phone to as the stopwatch.
Today we want to see the effect of temperature based temperature in the beaker based on the time. So today the experiment we have two variables, which is control variable and also manipulated variable. The control variable that we have decided, which is the time and the temperature of the water in the beaker, and the manipulated variable, which is the heater, which is Q, heat supply to the beaker. So we have decided two set points, which is 40 degrees Celsius and also 80 degrees Celsius. So based on the result that we have obtained, the graph that we want to plot, which is temperature against time, which is the y-axis is temperature of water in the beaker, and the x-axis is time, and the time interval of the water bath, which is 1 minute.
Here for this experimental is simple. The first one, we have to make sure the water bath is already 40 degrees Celsius. Since our set point, the first one is 40 degrees Celsius. And then after that, we put the beaker inside the water bath. Okay? And then we are waiting the temperature inside reach 40 degrees Celsius. But during that, we have to measure the temperature inside the water bath every 1 minute. We are using thermocouple. And then we put it inside, and then nappy will record it every 1 minute how much the temperature increase, and then how long it takes to reach 40 degrees Celsius. And then after that is, if already reach 40 degrees Celsius, we take out our water bath, and then we range the water bath again to 80 degrees Celsius. And then after the 80 degrees Celsius, we put in our beaker again, and then doing the same as the 40 degrees Celsius, take a record every 1 minute using the thermocouple, and then take a record by now. That's all the procedure for our experiment.
Okay, now we already come up with our results after do some simulation and control. So basically we got our GP from our non-linear regression, and our GP is 0.88454 exponential negative 2.37166s over 7.22839s plus 1. Okay, from our GP, we calculate the KC by direct substitution, which is our KC would be 7.239. Okay, from that, we come up with stability test, and we got a sinusoidal steady state.
Okay, basically we already find our GP. So we running our dynamic behavior, which is 4. First is IMC, second is ZN, third is CC, and the last one is ECH3112.
Okay, so the first method is IMC method. We're running the IMC method in PI controller, and then we put in our MATLAB, and surprisingly the result is quite bad because the time needed for the stability is quite long. So that's why we're having a lot of sinusoidal in our graph.
Okay, we compare the graph response for ZN and CC. Okay, basically both of the graph are quite same, but then the CC overshoot more than the ZN graph, and the time taken for CC take a longer time to reach stability compared to ZN.
The last one is ECH. So based from the result that we obtained, the graph shows that the ECH graph is less overshoot, and the time taken for the ECH to reach stability is shorter than others.
Okay, so we're comparing 4 of them. The first one IMC, the second one ZN, the third one CC, and then the last one ECH. And then the best response is for ECH because they're having less time needed to reach stability. And then followed by ZN, CC, and then the last one AMC. So it concludes that ECH method is the best one for our process.
Okay. Last but not least, to check the KCU from the manual calculation, we use MATLAB. We insert the equation into the MATLAB, and also we get the body plot. From the body plot, we get the KCU, WC, and also AR.
In conclusion, all the concept during our semester are applied in this project. So basically, we do assembling the data and build the transfer function models and do the dynamic response. From that, we test the stability and do the PID tuning. So with that, we can say that our project can be said successful.